Hey everyone, welcome to the next part of the Heroes Folly Devlog. If you haven't checked out the previous videos, now's a great time to do so. It'll get you up to speed on what the project's all about and all the progress I've made so far. Right now it's Monday afternoon, I'm just heading to the shops to get some groceries for lunch. I'm still working from home, so figured I'd walk, get some sunshine while we still have it. It also gives me a chance to update you on the project. I've decided the next task on the agenda is going to be enemy AI. While the current lack of visual feedback is bothering me, I'm pretty sure AI is more important to get right early on in the project, so the UI improvements will have to wait. I'm also really excited to learn more about nav meshes and state machines in Unity, and I figure my lack of experience in this space could blow the task out a little, so I'm better to start it sooner rather than later. I've got floorball straight after work today, and then a bunch of code to clean up after the mess I made in the last video. I thought of some ideas on how to tidy up the audio and combat code, so I think I'll take a shot at that tonight and check back in tomorrow evening. Make a start on the AI. I'll see you then.
Hey everyone, it's now Tuesday afternoon and I'm keen to make a start on enemy AI for this devlog. Firstly, I'd like to take you through some changes I made last night to the audio system. Because I was pretty inexperienced with audio in Unity, I started by following a tutorial from Brackies. This was a great introduction and gave me a much better understanding of the audio features in the engine. During implementation, however, I wanted an easy way to organize and play a random sound from a collection of sounds, so actions like swinging a sword or getting hit don't always sound exactly the same. I created this scriptable object which takes in a collection of sounds and offers a play method which plays one of them at random. I then added support for this in my audio manager, so standalone and random sounds could be played from the same place, by either calling play or play collection. Because sound collections are just a list of sounds, and sounds can each have a volume and pitch, the editor for the sound collections was super clunky. Rather than just make a custom editor, I decided to take what I'd learned about the audio features in Unity and overhaul what I'd written. So here's the new system. Firstly, I've created a scriptable object to define a sound. This is where we reference the clip itself, along with those parameters we mentioned earlier. We also provide a list of sounds, which is an enum of all the sounds in the game. This basically replaces the string representation from before, which needs a little more work during setup, but should be far less error prone during development. The audio manager is now a lot simpler too. When the game starts, we call initialize sounds. This goes through all the sound definitions that we've created, creates audio sources for each of them, and sets up the audio parameters. It then goes through each of the definition's sounds, which is that enum from before, and adds the audio source that we just created to a list for that sound enum. It sounds a little bit complicated, but it essentially leaves us with a dictionary or a map of sound enums to actual audio sources already configured to play the sounds. Because each sound is a list, we automatically support both playing a single and different sounds from a single call. The play method now gets the list of audio sources for the provided sound enum, then plays one at random. When there's only one sound, it'll just play that one. Otherwise, it'll play a different one at random. Here's a quick example of that when the player's walking around. Now, because each sound definition is just a scriptable object, it's so much easier to configure them individually. On top of that, you can select multiple definitions to apply common configuration. For example, by selecting all the footstep definitions and increasing the volume, I can make all the footsteps louder in one fell swoop. The way the loading of sounds is handled should let me also easily expand this when I want to start splitting sounds into different scenes to optimize memory and load times. And it should let me split up sounds into categories like background music, sound effects, and UI, and have game settings configure each of their volumes independently. All in all, I think it's a much cleaner system. If anyone has any suggestions on how to improve it some more, let me know in the comments. I'd love to hear from you. With the combat and audio fixes done, it's time to move on to AI. The plan here is to get the enemy moving around using a nav mesh agent. Once that's done, I'm going to make a start on the state machine and implement a few states. While I work on the AI, I'm also pretty keen to check out Bolt for Unity. It's a visual scripting tool that's now bundled with the engine. While I feel comfortable writing AI as code, I think AI state machines are often easier to interpret visually. So I'm keen to give Bolt a go and see how it fares when compared to just coding the logic. Right now I've got to make a start on dinner, but then I'll be back to start looking into the nav mesh stuff. Hopefully I'll have something to show by the end of the night. Well, some lessons learned when baking nav meshes in Unity. Be sure you have gizmos switched on in your scene view. Unfortunately, I lost much more time than I'd have liked figuring that one out. We got there eventually, so here's where things are at. To prove the nav mesh and the agent are working, I've hooked into when the AI detects a target. It's a very temporary solution until I've done some work on the AI state machines. When the character approaches, he's treated as a target and the nav mesh agent is directed to the target's position. I still needed to tweak the nav mesh agent properties to get it moving similarly to the player characters, and the animation syncing needs improving too. I do foresee a bit of a break for any substantial dev, between some video editing for the vlog and all the events I have planned for the weekend, so I'll get you up to speed sometime next week. Hey everyone, it's been a week since the last update. The weekend was full of Father's Day events and plenty of sport, but I did get a chance to catch up with my old game dev crew from uni, which was great. To update you on where we got to last week, the nav mesh agent movement is now a lot better. I wasted a heap of time following a tutorial, only to realise that all I needed was a few lines of code to get the animations working. The animation controller has two types of movement: free movement and targeted. Each of these blend trees are controlled with a few parameters: velocity forward for free movement, and velocity X and Y for targeted. To get the animations working correctly, I just needed to get the velocity from the agent, then scale it from the agent's speed, down to a value between 0 and 1, which is what the animator is expecting. I've only tested it for free movement so far, but suspect it'll work just fine when I add targeted movement for AI. I started looking into how to add the AI's behaviours last night, and came across a debate between state machines and behaviour trees. I was pretty keen to try out the behaviour designer asset until I found out it wasn't free. While behaviour trees do look like an interesting way to design AI, it'll have to wait for the next project. For now, I'll be sticking with a state machine and using Bolt to implement my states and AI behaviours. I could do this in code, but I find the visual interpretation of state machines pretty handy, and I consider it a good opportunity to try out Bolt's visual scripting capability as well. When I do get around to trying out behaviour trees, you'll want to make sure you're subscribed so you don't miss out on my opinions about each method. I put together a pretty simple wonder state last night. This is mostly from following a tutorial, but it's given me a feel for state and flow graphs in Bolt, and I feel comfortable enough to make changes where necessary. The plan for tonight is to start working on the new states. I'm not sure how long any of this will take, so let's jump straight in. So I followed another tutorial and ended up with this behemoth of visual script. It's meant to keep track of the players that are considered threats to the enemy, but it was originally just meant for a single player, and it doesn't work very well with multiple players. It's also huge. I became a little frustrated with how complicated the visual scripting implementation of this is, because I think I can do it in about 8 lines of code. But regardless, I'm assessing visual scripting, so I'm gonna be persistent. Instead of refactoring to code, last night I discovered Bolt has a thing called a super unit, which basically lets you define your own single nodes from a more complex behaviour. I've got an idea on how to use that concept and fix my multiple player problem at the same time, so let's see how it goes. Hey guys, it's Thursday now, and progress has been pretty slow, so I'm worried that this video will be a little delayed at this point, but hopefully the content will make it worth the wait. Yesterday I refactored a heap of my Bolt flow graphs. It took me a while to get them looking and feeling good, and after all that time, they're still not working. I can't blame it entirely on Bolt, as there were definitely some misunderstandings yesterday, like me not knowing that a flow variable was only scoped for the current flow, while a graph variable would remain in scope for an entire graph. I feel like an idiot for not figuring this one out sooner. I ended last night still having issues with my collider results, and after some late night thinking, I've come to the conclusion that I'm sort of wasting time. I told myself I was assessing Bolt, but the original intent was to use it purely for state machines. That quickly turned into using the flow graph system, as it seems that's the core feature of Bolt. And while I did enjoy what I was learning, I also know that what took me hours to put in a flow graph could have taken me minutes to put in code. I don't think I'm giving the tool a very fair assessment because I don't want to, nor do I need to use it for what it's good at. So starting today, I'm dropping it and moving on. I'm still really interested in the visual scripting concept, so instead of implementing it here and now, I'll be making another video getting some impressions from some colleagues working on their own projects. That manager from the first video that's actually released the game is going through a heap of Unreal tutorials at the moment, and is loving the blueprint system. The dev that worked on Spacey Boy 9000 is also doing a small project in Unreal. I'll be looking to get their opinions in the coming weeks, and I'm hoping that they differ, given that one of them is more comfortable with programming than the other. I'll do a separate video on that when I find the time. Now of course, we're still looking to improve the AI in the game. I've come full circle and have decided to try out behavior trees. I'll be using a tool called Node Canvas, which supports behavior trees and state machines, as well as dialogue trees, which I'd love to get some use of if this project becomes a little more serious. I know next to nothing right now, so it's off to YouTube for some tutorials. Hey team, it seems the theme of this video is going an entire week without any updates. I've been real busy with a ton of events, which I'm certainly not taking for granted given how lucky our state is with COVID right now. But because of that, any time I've had for game dev has gone straight into that, so I've been pretty slack with camera and screen recordings. Regardless, I'll try and give you an update with where things are at. It took me a few days to wrap my head around the basics of behavior trees and node canvas, and even now I get stuck too often. I think I've got enough knowledge now for my Goblin AI, and I've actually really enjoyed both the learning experience and the result. So I'll be upskilling for future AI behaviors, and I'm really excited to try out more complicated behaviors for individuals, groups, and bosses. I got my state machine as far as having a wandering state, with a behavior that looks like this. All this is doing is recording the spawn point when we hit start, then looking for a player, and finally wandering around. Now, something to note is that I've already done some custom actions and conditions here. Node Canvas came with a wander script, which works with a nav mesh, but I found my enemy was wandering all over the place and could end up on the other side of the map pretty quickly. I wrote this wander near spawn behavior, which uses the spawn point we saved and makes sure the agent never strays too far. When it came to player interaction, I wrote this check perception condition. Basically, it just keeps track of any players that have entered a pretty large radius, then looks for one of those players in its line of sight. It's pretty simple for now, but I've got plans to spruce it up by adding some mechanics which will allow players to sneak up on enemies by walking slowly behind them. And I'll also be trying to tie it into a sort of D&D style perception check, so characters like rogues can sneak around easier than warriors. Once wandering was done, I wanted to add an attacking behavior. Only one problem, so much of my code was spaghetti from when I jammed combat mechanics onto the player that all of a sudden it was real difficult to cleanly do anything related to combat for the AI, especially through Node Canvas. It took me a couple of evenings, but I've now heavily refactored my combat mechanics, and I'm pretty happy with the results. The Behemoth combat controller is no more, completely removed from the game. Instead, most of its functionality has been moved into mono behaviors that each perform single tasks, and have delegates to support a sort of publish-subscribe system. Here's an example. This script just keeps track of a target, nothing more. We allow external entities to change it, and when it changes, we notify anyone listening via the delegate. The target range checker gets these notifications, and when a target's available, it does range checks to see if the target's close enough to engage with or look at, and also close enough to actually attack. Other than that, it just broadcasts changes to that state to whoever is listening, again via delegates. We actually have a couple of things listening for state changes to this. Firstly, the player movement listens for when we're inside the engagement range, to modify the speed that the player moves when it's in combat. Then we've got our player GUI, which listens for changes to the attack range and updates the target UI elements accordingly. The auto attack ability also listens for changes to the attack range, so that when we're close enough to the target, the attack can occur. Speaking of abilities, I was given a suggestion by a mate, you know who you are, on how to refactor some of my ability code. I've mostly done that, but think there's a couple of small improvements that I can still make. I'll be looking at adding player and AI abilities in another video, so when we get there, I'll run you through the system to see what you think. After all the refactoring, I still don't have AI doing anything after the player's perceived, but I think we're in a good spot to implement that now, and once that's working, the death state should be a piece of cake. They're the last things still to do in this video, so let's give it a go. Hey again, it's been a few days since the last update. We're now at Sunday morning and it's been a pretty challenging few days. I thought I had this behavior tree system figured out, but I was very wrong. Implementing the behavior for attacking had me stumped for quite a while, but I'm slowly starting to understand node canvas and behavior trees in general, and I managed to wrangle this together eventually. Certainly doesn't look like much, but lots of thinking and some custom code went into it, and it should translate into this job being a lot easier in the future. I did a heap more refactoring yesterday too. I was having a rough time with the AI movement animations, and that stemmed into a bunch more code changes. After all of that, I finally managed to get the AI to a state that I'm happy with. So let me show you. Like before, the AI wanders around until it notices a player. Right now, it'll see a player in front of him, or if you get a little too close. At that point, it moves into the attacking state and it'll start hitting me. I haven't given the AI any weapons yet, but that shouldn't be too complicated to add when I get around to it. I also haven't implemented player death, so the AI won't give up until it's been killed. I can still attack and kill the goblin, at which point it transitions into a death state, which is empty at this moment, but gives me some options to add things like resurrection abilities and possibly even loot generation down the line. To add a nice touch, I made this call for help action. When the goblin transitions into the attack state, he'll shout for assistance. The action returns true if someone hears the call, and false if there's no one around. I'm not using this result in the behavior tree just yet, but I think it could work well for weaker enemies that might not have the morale to attack the player without some help, and could make them flee instead of attacking. And that's about all I've got to show for this devlog entry. All of this work with AI combat has made me realize that some of the original plans for combat are real finicky to manage on a gamepad, and they feel like the start of a not very engaging combat system. I am glad I'm starting to see this now, as it should give me a chance to play around with it before getting too deep into development. I'll likely toy with some new ideas in the coming weeks, and I'm real keen to lay out some UI elements into the scene too. I hope you can check out the next videos to see how it's all progressing, and offer some feedback as I go. If you enjoyed the video, be sure to hit the like button and leave me a comment. It helps with getting more visibility for the devlog and the game, which will hopefully translate into a better game by the end of it. Thanks for watching, and I'll see you next time.